Hello everyone. Today we will be seeing what are polynomial equations. We will discuss the two categories of polynomial equations that we are having over here. First one is real polynomial equations. You must be aware of what real numbers are for this. Real numbers are any number that basically can be represented on the real line. They can be rational or irrational. You can think of any integers, any irrational numbers like pi, root 2, all of them are real numbers. So a real polynomial equation can have only real number coefficients, which is point number 2 over here, and real number variables, which is point 3 over here. Now, as long as an equation is polynomial, regardless of whether it be an integer polynomial equation or a real polynomial equation or a complex polynomial equation, the powers of x are always supposed to be only whole numbers. Whole numbers, you would remember, are numbers starting from 0, 1, 2, 3, and all the way up till infinity. As some of the examples of real polynomial equations, we can see, for example, this one, where the coefficients are all real numbers, 2, 3, and minus 9. And you can see that we are only having whole number powers of x. For the second case as well, pi, remember, is an irrational number. Pi is not 22 by 7. Pi is not 3.1415926. Pi is an irrational number, which is basically the ratio of circumference to diameter of a circle. Irrational numbers are also real numbers, so we can very safely use it as a coefficient in a real polynomial equation. On the other hand, if you see some of the contradictions that I have listed over here, you will see root x being involved in one of the equations. Now the power of x over there is 0.5 because x raised to the power 0.5 is root x. So that cannot be a real polynomial equation because the power is not a whole number. And in the second one, whenever you have things like sine x, tan x, logarithmic x, e power x, sine inverse x, all of them are not polynomial functions. Basically, these are series of infinite powers of x. You can write a series expansion for sine x, which will contain all the e odd power terms, which goes all the way up till infinity. Therefore, sine x is not a polynomial function. We have very similar class of functions even for complex polynomials, just that instead of real numbers, we will be working with complex numbers. Uh, if you're not aware of what complex numbers are, then uh, feel free to read more about it and then view this content. I will cover complex numbers in a separate video. This video, I believe, is not the right scope for that particular information. So, for those of you who are aware of complex numbers, a complex polynomial equation needs to have only whole number powers of the component. First of all, the coefficients need to be complex numbers, the variable needs to be complex numbers, and the exponent of the variable still needs to be a whole number. So these are restrictions that are pretty much similar to what were there in the real real polynomial equation. As examples, we can see that, for example, for equation 1, you have 2i, I is basically iota, and z cube, z or z, however you like to pronounce it, is basically any complex number over here. So you can see that the coefficient of the leading term, that is z cube over here, is 2 iota, 2i, and it is real for the z square. All real numbers are complex numbers, so it is safe to say that 3 is a complex number because real numbers are a subset of complex numbers. And then you have I power I. Now I leave this as an exercise to you to comment it out whether I power I is a real number or a complex number. It is definitely, well, real numbers are complex numbers, so basically you have to tell me if I power I is purely complex, purely real or not. And for example 2, it might look like a copy from the example 2 over here, and to be honest, yeah, it is a copy. I actually copy pasted. Over here I have just replaced z with x. I have done this intentionally to show you that we can as well use just real numbers for a complex polynomial equation and call it a complex polynomial equation because real numbers are complex numbers. Degree of the equation is defined as the highest power, or basically the power of the leading term. So for example, for this complex equation, the degree is 3. And for this complex equation, the degree is 2. And it doesn't really depend upon, the definition of degree doesn't really depend upon whether we are talking about degree of a complex polynomial equation or a real polynomial equation. So I'll leave it to you to understand the degree of these two real polynomial equations. They're very similar, so I hope you should be able to figure this out. The last part of this video, we can end it with seeing some contradictions for complex polynomial equations. The reason I have also written over here, you can see that 1 by z is basically z power minus 1, the exponent not being a whole number. And over here as well, the coefficient of even one of the terms, you have a term whose exponent is a whole number, but even if you have one term whose exponent is not a whole number, you cannot call it a polynomial equation. 3 by 2 is 1.5, which is not a whole number. Therefore, this cannot be considered a complex polynomial equation. I hope you have found this video informative. For any doubts or clarifications or suggestions, please leave a comment. Thank you.